Yeah, today we are going to discuss about yarn and name node high availability as related topics for Hadoop 2.x. And today agenda is we'll going to understand what is yarn. I hope you have heard about the word yarn on Hadoop. And after implementing this feature, Hadoop is taken as next generation platform. How it is beyond MapReduce. What is there in MapReduce? And what is beyond MapReduce? Okay, and the yarn use case and the top view of yarn working and the life cycle of yarn application. We'll come to understand resource node manager and map reduce, and finally name node HA. So I think before going to in this topic, we'll have a quick look of the Hadoop 1.0 architecture so that we can able to understand it better as we have discussed long back. Okay, we'll be having one name node, multiple data nodes. So all the data node and name node will be interconnected to each other as it forms a cluster. Okay, on Hadoop 1.x, Hadoop 1.x, as we have discussed, we'll be having a HDFS, Hadoop Distributed File System, okay, and MapReduce. Okay, in HDFS, the master service will be the name node. MapReduce master service will be the job tracker. And the slave will hold the actual data, that's data node, we call it assets, and each and the name node, data node, these and all called JVMs or daemons, Java virtual machines. And here the slave service for job tracker will be task tracker. So now we are going to discuss about the methodology of this, especially this MapReduce. Okay, we are going to discuss about how the functionality will be there. No, whenever we request to submit any job, in order to process any task on this Hadoop cluster, how it will be taken on the request and all, how it get performed and all we are going to see. As we already seen the HDFS data storage and data retrieval from the HDFS through the name node. So okay, just assume that as we are having the name node which holds the metadata information, and we will be also having the master service running on the master system for job tracker. In the same way, we'll be having data node and task tracker running on the slave system. Okay, if you have any question in between, you can ping me. I'll respond to that. First of all, let me explain this concept. So each and every machine we will be having data node and task tracker running up and running. So we have a client machine where we'll be requesting the master Hadoop system to take this job. Okay, how the process will be. Okay, and MapReduce, the thing we have to keep in mind in MapReduce, as everything this Hadoop framework is developed on Java, we'll be writing the code. MapReduce can understand only Java program. It's not like that we need to write the program on Java only. We can write in any other language, and using Hadoop streaming, those code which is written in any other language, that will be converted into Java. So because Hadoop itself is developed on top of Java with the help of Java, so it can able to understand only Java code. Okay, MapReduce uses only Java programming to process. In this, we'll be having two set of process: map task and reduce task. Okay, we'll be having two process. One is map task and reduce task. I'll let you know what is meant by map task and what is meant by reduce task. I think it's better to discuss about the name node availability tomorrow. Today we need to completely understand about this map reduce functionality. Okay then. Okay, we'll be writing the map and reduce program. All together we'll be combining into one Java program. Okay, later this Java program will be compressed in .jar file. Okay, we have to the program name .jar. We will be writing the Java code .class that will be converted to .java, and then .java will be converted into .jar. Okay, so finally I'll let you know the procedure of how to convert the from how to export that into a jar file. Okay, so let's be simple. We will be having one jar file which has all the details of the program, or the complete business functionality will be implemented on the code format. So we'll be having the jar file. So whenever we request, whenever the client requests to submit any job, so it will have the .jar file where all the job configuration will be given in this file. Okay, so client will be requesting to submit a job on this master node. Okay, job submission request has been taken by the job tracker because it is responsible to process, it is responsible to manage, and it is responsible to complete the task which is assigned by the client. Okay, it has to manage and it has to lead the jobs, okay, which is the processing on the Hadoop cluster. So job tracker is a master. As it is a master, it has all the responsibility in order to take care of that particular job, it's completed or not. Okay, fine. It got the program details, configuration details from the client machine in terms of jar file. So job tracker will go through those files, go through that program, and come to know. So will be specifying the input location while submitting a job in the command. Okay, and through that command will come to know that input location it's there. So it will directly communicate to the name node. Okay, so can you please check this input file is present or not? Okay, job tracker will check with the name node. So please give me the details of this input file which is located in this location. So name node, from the name node you will be getting those information from the metadata. Okay, data above the data. So there will be in that metadata we will be having the complete information about the data locations and its how many blocks it has been splitted. All this information will be there on the name node. So job tracker will then refer to that metadata information. It will come to know. So from let's assume 1, 2, 3, 4. I have 4 data nodes. So from that metadata information, it's come to know the required file is stored on 2, 3, 4. Okay, the required file is stored on 2, 3, 4. As we have 3 replication, so we will be having the data will be located in 3 different nodes. Okay, so based upon the and also it will give the block information wherever the block is located in those data nodes. Okay, so after getting that information, job tracker then communicate to the task tracker where the data is located. That particular data node will be having task tracker up and running. Okay, job tracker will communicate with the task tracker. So we got a job, we have to start processing it, and so and so blocks are there in the data node on your neighbor data node. So can you get those data from the data node and start processing it? Okay, this program jar file will be passed by the it will be given to the task tracker to take the process. It will it will initiate the process from on this task tracker. So after getting that file, task tracker starts the process After it will get that data location, data from the data node. It will start processing it. Okay, and no, it has to give the status of those process to this job tracker. Okay, job tracker will be keep on updated with the status of this task tracker. If any of this task tracker fail, okay, let's assume I have 3 blocks of one file. So those 3 blocks will be there in 3 different nodes. Okay, if any one block has been corrupted or there is any problem, so task tracker is failed, something the data node is failed means we cannot able to process it. Okay, so that in that case job tracker will come to know so and so task tracker got stopped, so the data node is inaccessible. So we have processed 2 tasks on these data nodes. Okay, and its responsibility to take the failure case. It has to find the other replicated block where it is located, and it has to restart that process of that failed task. Okay, this is how the operation works. And finally, after everything is getting processed, and the output of that particular job will be returned to the output directory. Any question in this process? Nasim, Sahitya, able to understand? No. Okay. No, let me know if it's not clear. I can able to understand you one more time. Just it's a simple thing how the job tracker manages the task tracker. The similar way how name node manages the data node. Okay, thanks. Yeah. So this is the actual functionality or the this job tracker will be taken care. So actually where I'm speaking about the map reduce, we'll be having 2 tasks, right? Map and reduce task, and we'll see how it is exactly what is map task and what is reduce task. I'll show you one more so let's assume, sorry, let's assume I have some file. I have some text file like hi, how are you, how's your health, how's your work, just some input file. So it's fine, that's enough. Why I need to make a big thing? Okay, let's assume this file is having the size like 200 MB. Okay, so if it is 200 MB, how many blocks will be having? As the default block size is 64 MB, we'll be having something like let's assume a.txt is one block, one split of this it's having 64 MB. b.txt is having 64 MB, 128, right? And the c.txt equal to 64 MB, so 196, right? t.txt, the final block will be having only 80 MB. Maximum it can hold only 64 MB, so that is the reason the last block is having only 8 MB. So we have 4 blocks here for this input file. Let's assume it's having the size is 200 MB. We'll be having 4 blocks. Okay, for this file, it has been let's imagine it's already saved on the. It has been already stored on the HDFS. So name node has all this information. Okay. So this is that 200 MB file. Where we'll be having multiple blocks. 4 blocks. The data has been stored on 4 blocks. And the last one is we'll keep like so for 4 blocks we have 4 lines, something like that. Okay, let's assume I have in one block, hi, how are you? So now we are going to discuss how actually the internal process runs, so that you will be getting the complete picture of MapReduce flow. Now we are going to discuss about the MapReduce flow. Wish your health. Your work. In the last 8 MB we will be having only 2 words, something like that. Hi, hello. So these are the input splits. These are the blocks. Okay. So we can call it as a block or input split. There is a difference between that input split and block that I'll explain later. That will get confused. Okay. We'll see in next class. Then there will be difference between block size and input split. The block size is the one will be having the 64 MB. Input split is the other one where the map and reduce task will be initiated based upon the input split. Just assume the blocks and input splits are same. Okay, we have 4 input splits. So like let's assume these blocks are there with the data nodes. So for each and every block we'll be going to process that blocks using the program directly on the data node with the help of task tracker. So if we have 4 blocks, if that is the case, we'll be processing parallel in 4 times, right? For different blocks, different data which is there in the data node. So we are going to process 4 different process for the different data in the data nodes. Okay, job tracker is the one is going to send the program details how we need to process the data. So task tracker is the one who going to take that data from the data node, start processing. So we'll be having multiple task tracker. So how many number of processes we may have, it's equal to the number of blocks we have. Okay, just assume number of input splits we have. Based on the input splits, we'll be having those many number of processes. Okay, we'll be having, so whenever we write any program, we have to mention like what type of file format is this. Okay, by default, if we don't mention anything, by default it will assumes like text input file format. Text input format is the default one. Is the default file format. Okay, we will be configuring all this information on the program while writing the program. Okay, based upon this input file format, okay, it will get readed the way it will try to understand the file data and all. It depends on it. Okay, we'll discuss going forward. We'll be having for each and every block will be this individual process. Okay, for each and every process we'll be having one record reader. Whenever we start processing any request, we'll be having the record reader. This is designed on the framework level itself. It will take care. It helps us to split the input data into key and value pair. Okay, I will tell you. So in Hadoop, whenever we are discussing about the map and reduce program, this map task will process any data in key and value pairs. Okay, as when this reduce task also will process in terms of key and value. So in this way, what are the data it may be. So in Hadoop we are going to process in this type of format, key and value. Okay, we'll be having one key and one value. This format, this pair, with the help of this pair, we are going to split the data and we are going to process. That is the only way Hadoop can able to process this huge amount of data. Okay, so based upon the input file format, the record reader is responsible to split the input data into this key and value pairs. Okay, record reader, it's responsibility to split the input data into key and value pairs. So fine, if the file format is text file input file format, text input file format, so record reader will read the data sequentially. So it will read the data sequentially and it will split the data into key and value pair. Okay, let's assume if the text file input file format is the input file format, so the key will be offset address and the value will be the entire line. Okay, what is meant by offset address then? Yeah, something like the offset address in the lens here it's 0. The offset address is 0. Okay, for the first split the offset address is 0. You can understand it better in this way. The offset address is 0 and the entire line is the value. Hi, how are you will be the value. Okay, for the next line, okay, like 0 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 slash n. So 15. So the next line will be the offset address will be 15 and the entire line will be the value. So the length of that line will be the offset address, the entire line will be the value. Okay, able to understand how the key and value pair will be decided based on the input file format. Okay, you can ping me whenever you have any question and all if you didn't understand. Yeah, so this is the offset address. It will be converted into key and the entire line will be the value. Record reader is responsible to convert these key and value pairs. So later record reader, it will be given this key and value pair to the map task, the actual task we have. We'll be having multiple map tasks. We'll be having multiple map tasks. Okay, so fine, here the key will be 0, the value will be hi, how are you. Okay, in this the key will be 15, the value will be how is your head. Okay, in the same way other two also will be there. Okay, will be processed. So this key and value split will be the input to this map. So as map task can understand only key and value as an input and also it will give the output in key and value pairs only. Okay, it will read the output of this record reader. No, this and all taken by internally with the framework itself. We have no control over this map while writing this map code, where we actually implementing the business logic. So our task is to, so the task of this job is to, we have to find the number of repeated words, the word count job. It's a kind of hello world job. No, I want to find the how many number of repeated words. Okay, it's happening. It seems how is 2 times, is 2 times, u is 2 times. Okay, something high is 2 times. So I have so many multiple number of words. I want to count the repeated number of words. So I need that count. I need to aggregate that count. So that is my task. Okay, how I'm going to implement in map task. We'll be going to, in order to find the count of each and every word, we have to split the value where the entire line is there, right? So each and every word will be delimited in the space. Okay, we have a space in between each and every word. Based on that space, we are going to split this value. Okay, how we are going to implement the logic such a way, like we are going to split the value based upon the space, and we are going to assign the word as a key and value as a 1. Okay, we are going to do like this in the map task: hi comma 1, how comma 1, r comma 1, u comma 1. So here we are going to split the value. So here we are not taking care of any, we are not no, we are not going to use this offset address key. Okay, we are going to leave it as it is. We only use the value here in this case. In some other case we may need that value, we may need that key also to work. Okay, in this scenario I need to count the number of repeated words. It's is required only by using the value itself. Okay, we will be splitting the entire value, the words, and it will be delimited with the space in between, right? Based on that I am going to split that. I am going to assign that each and every word into a key, and I am going to assign a value as a 1. Okay, I have given like this. This will be the mapper output. Okay, this will be the mapper output. So from mapper I am going to get this output. So for each and every map I am going to get this output. After that we'll be having sorting and shuffling phase. Okay, all the mappers will be getting similar output. I'm going to aggregate sorting and shuffling. Sorting and shuffling phase. No, we are going to actually shuffle the key and value pairs of the output of these map tasks in such a way, like ascending order. Okay, hi, how are you? In this case the output of this sorting and shuffling will be r comma 1. So as the alphabetic starts with a, so ARE will come first, right? In this similar way the sorting and shuffling will happen among all these output of this map and map task outputs. It will be done internally on the local file system, not on Hadoop. Okay, this sorting and shuffling phase will be done on local file system. It's a temporary storage. Okay, it's a temporary task. After doing this, this and all will go together as an input to the reducer. Here comes the reducer. Okay, this output of this sort and shuffling phase will be the input of this reducer, where we'll be having the reducer. Reducer in the sense we'll be going to run the reduce task. Okay, in reduce task we need to write a logic to compare the key. Okay, I'll be holding the key ARE. Okay, if and I'm going to increment the value 1. So each and every word will have a value as 1. If any other I will be looping the entire output. Okay, if any other value is there with ARE, key with ARE, we are going to increment the value that from 1 plus 1, like so. In this way we are going to aggregate that. We are going to compute that, get the desired results. Okay, after getting this we'll be getting the complete output here. Okay, from the reduce task, like I have how comma 4, something like this. Okay, we'll be getting something like this out with the total aggregated value and the key and the word of that key. Okay, this will be given to the record writer. The output of this reduce task will be given to the record writer, where, one second, record writer is responsible to write the output to the file. Okay, to the output file. While writing the program, we can't give the output file name. We can give only the output directory. In that output directory, so it will framework as the control over writing the file name. Okay, we will be giving only the output directory. In that particular directory, it can write the output file. So output file will be named in like a path hyphen 0000 something. So it will be the output file name will be like this. Okay, if I have my no, it's not like that I should have only one reducer. We can have multiple reducers as well. The output file will be equal to the number of reducers we have. Okay, so I am done with this flow. If you have any question in this, you can ask me. I think. Hello, hello, are you there? Hello, Sai.
Yes, I'm there.
Yeah.
Yeah, I'm here.
Yeah, able to understand. It's a bit
I can
confusing or what?
Yeah. Everything is clear. No more dots, I think so.
I got a question from Naseem, like how do we determine output file? So we can give a that the type of file, like how I explain you. The output key type and value type, they will be having some data types, okay, that we can control while giving the configuration, how what type of output file we need. But my point is we can't have control over the output file name. Okay, we can specify only the output directory, but the output file name we can't able to specify, because in Hadoop we will, all the process happening in parallel. So it's not like we will be having only one reducer, we can have multiple reducer. So if that is the case, we'll be having multiple part file. If I have only one reducer, the part hyphen 000 will be the file. If I have two reducers, part hyphen 000 and 001, and we'll be having something like that, incrementing that no extension with 1 2 3. So it's something like that. Okay, we can't have control over the output file name. That's my point. So we can specify what type of output file we need, but we can't specify the output file name. Okay, so that's what and here this complete functionality you can able to understand while when we write some program and execute. That will be better. Just for your understanding, no, it's just interview question as well, the certification question as well. The record reader is the one who is responsible to split the input file into key and value pair in such a way based upon the input file format given on the job. So that will be the input to the map task. The output of the map task will be sorted and shuffled. Later that sorted and shuffled output will be given to as an input to the reduced task. From the reducer output will be given to the record reader is responsible to get the output from the reduced task to the output file. So this is how the flow works. Okay. In between we have some other concepts are there, combiner, partitioner, that we will explain when going in depth into the session. Okay, is that clear, Nasim and Saitya? I think I can move forward. Yeah, fine. Thanks. So in order to understand this yarn, we need to understand the map reduce flow completely. So let's have a look of this. Oh, I think this is not sorry. So yeah, I think you got some idea why the data is split into multiple blocks. So well, no, if we divide the data, then we can divide the process as well. Okay, that's the main agenda. The way how my name node and data node works, in the same way job tracker and task tracker also work. Internally, the map and reduce task will take care of that parallel processing. Okay, so let's quickly go through this PPT. What all the concepts we have discussed on this paint, same thing has been explained here. Okay, large scale data processing was difficult, that is we know. So by using Hadoop, we can process a huge amount of data. That's the scope. Managing hundreds or thousands of processor, managing parallelization and distribution. That's called will be distributing the data and managing the parallel processing on it, and input output scheduling, status and monitoring. So the entire status can be monitored to the web UI. That's a job tracker web UI. We'll be discussing that the configuration details. We'll come to know what are the address to browse the job tracker, what are the address to browse the name node, where we can browse the entire HDFS file system through web UI. So that will show where there we can able to monitor the jobs and all. Okay, and if there is any problem in any task tracker, it can able to recognize that and can restart this failed task in some other data nodes. Okay, so all these kinds of things will be provided by the MapReduce. Okay, yeah, Hadoop MapReduce is a software framework for easily writing application which process vast amount of data in parallel on large cluster, and again they are mentioning the same thing, we can process it in parallel of commodity hardware in a reliable fault tolerance manner. So the programming model was given by Google. This MapReduce concept programming model was given by Google, and it was later implemented by Yahoo and given to the open source, and all combined together we call it as a Hadoop framework. And even HDFS is also developed by the basic concept which is given by the Google, which has a Google file system. Based on that concept, we have developed a Hadoop distributed file system. Okay, a combination of map and reduce model with an associated implementation, that's called MapReduce, obviously. So able to hear me properly? Yeah, fine, thanks. Okay then. Okay. Oh, sorry. That is the PPT. Yeah. So yeah, MapReduce is highly scalable and can be used across many computers and answers all problems mentioned earlier. So that is there. It means a fault tolerance, everything it can able to. The job tracker is one who is responsible of taking care of all the jobs. Okay. So many small applications can be used to process jobs that normally could not process by the large machine. Yeah. So it means one single large machine cannot able to process this kind of huge amount of data at once. So on combining too many small machines, we can do that. Okay, it's something the concept like altogether we can success. So programming language supported no, it's a Java or else you can use Python, Ruby, Perl, except no some other languages also, which internally converted into Java program by using Hadoop streaming. Okay, and also we can use C++ also to write any application on this MapReduce. Okay, and yeah. So MapReduce used on Google, Yahoo, Facebook, and Google they will be using for Google search. They'll be internally using MapReduce where they will be collecting all the web data, and will be having some index. Based on that, they will be searching that required web pages and giving the results on that Google search page. Okay, they have the huge amount of cluster on Google, and Yahoo also same thing while doing the Yahoo search. Facebook, they implemented this MapReduce concept for data mining, ad optimization, spam detection. So like fraud account, fraud Facebook account, something like that, fake Facebook account, too many duplicate accounts, something like that. In order to detect this kind of activities, they have implemented this Hadoop. Okay, in Facebook, not only MapReduce, they almost use Hive and all, Hive Pig as well. Okay, that is the thing. So as we discussed in Mapper, we'll be having key and value pairs. Okay, map reads the data in key and value pairs only. It may not understand any other different format. It will understand only key and value types. Okay, output also will be in key and value types. Okay, that's the main thing we need to understand. So mapper may use or ignore key. So it's our no, it's up to us. We can use that key or we can ignore that. But most probably we'll be using the value in everywhere. Okay, as I said in the no text file input file format, we didn't use that key, that offset address. So that's what the key is offset, byte offset into the file at which the line starts. The value is the content of the entire line itself. Typically the key is considered irrelevant. So in that case the key is something like it's irrelevant to the task what we are doing. It's not necessary to use that key, right? So that is the reason we have ignored that. So if the mapper writes anything out, the output must be in the form of key and value pairs only. Something like the mapper output is also in key and value pairs, where we can see the value is splitted into multiple key. The word will be as a key and the value we have assigned as a 1. Okay, where we have formed a key and value pair. Okay, so these are some examples are there. We'll see. In reducer also same thing. Or after map trace, all intermediate key values are combined together for a given intermediate key into a list. So it's something like sorting and shuffling. Okay, all values associated with the particular intermediate key are guaranteed to go to the same reducer. So the second point states that's a partitioner concept. That's a different concept again. That's a big concept. I will discuss that later. The task which is mentioned, the second point, will be done by the partitioner. So partitioner will be implemented after sorting and shuffling phase, where it will determine the what type of key and value type has to go to which reducer when we having multiple reducer. I have 4 reducer, so I want to go 3D, no, 3 length word will be going to the one reducer, 4 length words should go to the one reducer, something like that. Based upon the length of the word, I can specify the program, so I can route the output to those reducers. Okay, so that is the again different concept. I'll discuss about that second point. Okay, later. No. So the intermediate keys and their value list are passed to the reducer in sorted key order. This is known as shuffle and sort phase. Reduces uh, outputs 0 or more key and value pairs. We can use a dummy reducer where we will not give any output, or else we can get the desired output on this reducers itself. Something like that. It's up to us, our business logic. We'll be getting the desired output on the map task itself, or else we will be implementing the reducers to get our desired output. Okay, something like that. If we don't use reducers, internally we will be using identity reducer. It's a framework one. Okay, where we will not get any output. The same output what is there in the map output, and the identity reducer will combine all those map output and will give the same thing in one file. Okay, that's the use case in identity reducer. Okay, in the same way, if you not specify any map task, we will be having identity mapper will be running. So whenever we submit map reduce job, we map and reduce task will be the compulsory one. Okay. Okay, you can have a control over the reducers. You can stop this identity reducers as well by mentioning the no. There is some property in the job configuration in the driver code where we will be mentioning the reducers, how many reducers we need. So do we need identity reducers or not? All these things will be mentioned on that driver code. No need to worry. When we go into the program, each and everything we can discuss. Each and every property there in the driver code. No worries. Okay. Yeah, just want to understand about the reducers and all. So how many mappers and reducers? Maps usually as many as the number of HDFS blocks being processed. That is the default. Else the number of mappers can be specified as a hint. So the number of maps can also be controlled by specifying a minimum split size. So here the split size, the input split size, okay, is the one who is going to responsible to get the number of mappers. Okay, the input splits again based upon the number of blocks we have. Okay, the data, actual data. Okay, and how to decide how many number of reducers we need based upon the number of map tasks we have. If we have 2000 or 3000 map tasks, for those 2000 3000 map task output, if you use only one reducer, it will take lot of time to process, because one map task will run on one node. Okay, one data node. So all this output will be routed to the one single data node, where we will be using, where we will be using the single reduce task. So the load on that single reducer will be more. In such cases, we will be going for the multiple reducers. So where we can again divide that load into multiple parallel tasks in the reducer space as well. But actually, the number of mappers we have, it's always less than something like the number of reducers is always less than the number of mappers. Okay, able to understand me this point? Okay then, and this is the word count example which I have explained now. We'll be having multiple inputs, and it will be divided into multiple splits, and these are the output of this, and finally we'll be aggregating it and we'll be writing into the one single output file. Okay, divide and conquer. So as I said, this is the input file. We'll be having multiple maps, and in between we'll be sorting and shuffling the map output, and here then we'll be routing that to the reducers. Okay, where we'll be having a two output file from these two reducers, and using some Unix script, we can merge that two files into one file. That's up to us. Okay, this is how it works. Here you can see two reducers we have. It means we have internally we have implemented partition here. It's not drawn here. If we have partitioner, then based on that, this output of this sorting and shuffling will be routed to these reducers. Okay, if we don't have partitioner, in that case, if we have multiple reducers, in that case also it will split the data. Okay, it will equally split the process of these reducers. The first half will be there with the one reducer, and second half will be there with the other reducer. Okay, I think you got the some picture outline of the map and reduce program. Yeah. So same thing, whatever I explained in that paint, they have explained the same way here. Okay, you can see A, C, these and all go into this reducers, and these and all goes to these reducers. It's up to framework, it will decide, what all the outputs it will be if we don't have partitioner in between. If we have partitioner class, if we have some code in that, we can direct the output of this mapper to those reducers. So these are the key and value types they have. We'll be summing the values, means 1 comma 1 comma will be having some aggregation of that value. Later we'll be summing that value. We'll be incrementing that value basically. So resource requirements, in order to process, we need a system with a processor capacity, use of commodity machine, then supercomputers, lots of storage space, and we are bringing the computation near to the data. Something like it means we are bringing the actual program logic to the logic to the data, near to the data, where actually the data is there. We are directly transferring the program from one place to another place instead of transferring the data from one place to another place. Okay, need a reliable coordinator, distribute the data, coordinate the task. So distribution of data will be taken care by the name node, will be managed by the name node, and coordinating the task will be taken care by the task tracker and the job tracker. Okay, the challenges, we have some small challenges here. A task on mission can crash. Okay, something like if there is any failure on the task tracker, that particular task will be failed. A task on mission can run very slow. It is also one of the case, and a mission can crash. So these are the different types of scenarios that talks about there will be a failure on the data node. In the sense, there will be failure on the task tracker. Okay, in that case we may lose that particular process. There may be data loss while data is being moved. Okay, whenever the data is copied from the client to the data nodes, in that particular process, the data may get corrupted. There will be these kind of challenges also there. So coordinator has to be very reliable. Coordinator in the sense like the job tracker is going to coordinate all the tasks among the task tracker. The job tracker should be very reliable in order to monitor these kind of activities. So it's a kind of challenge in order to maintain the job tracker in a very reliable thing. As we have only one job tracker, so we should be very careful while configuring or giving the system resources to the job tracker. Okay, corpus division among us nodes need to be fairly equal. Something the resource utilization among the node should be always be equal. That also maintained by the job tracker. These are some set of challenges that also will be overcome by the Hadoop 1.0. It's up to some limit we can avoid these kind of challenges, but few of things cannot be avoided because as we have only one job tracker, it may fail at any time. If any task tracker fails, we can restart the task required task in some other data node. So if that job tracker itself got failed, then we cannot submit any task, and it will all the tasks in the job related to that job will get failed. Okay, even though the task tracker is up and running. So in such kind of scenario, we can't able to do anything. So these kind of scenarios and all will be handled on YARN in Hadoop 2.x. There it comes the use of YARN. Okay. So I think after understanding this concept, then it's better to go with that YARN and Hadoop name node HE and all. So these are the in this picture, what are the details we has to provide while the user is writing any program. I think it's going more than 1 hour. Please be hold on. I'll complete this concept. Okay. So user has to give the job configuration detail, what type of input file format it is, and the input location where it is located, and he has to give the map functionality, and also he has to mention number of map reduced tasks he need to have, and that he has to specify the reduced functionality as well, the actual code, and what are the required output format he need, the output key type and value type and output format, and where do we need to store that output location. These are few set of information user has to provide. So framework will take care of splitting that data into key and value pairs based upon the input file format, and starting the individual map task, that all will be taken care by the framework. Shuffle, partition, sort per map output, that also will taken care by the framework itself. So merging, sort for map outputs for each and reduce task. So all these kinds of tasks will be taken care, and finally reduce task will be initiated after immediately after completing this sorting and shuffling and partitioning and all. So later finally it will the output will be given to the output file with the help of this output format with which we have configured. Okay, I think it's clear now. Again, the same thing which I have explained in the paint. The input split, the record reader is responsible of splitting, converting this key and value pairs. Okay, the record reader cannot read all the data at once. It will read record by record. Okay, it will read the first line and it will convert into key and value and will given to the mapper, and next line it will convert into key and value pairs and given to the mapper. So it will read line by line for that particular data block. Okay, so finally we'll be getting mapper outputs, key and value pairs. So I will be having partitioner. We'll be redirecting the output of this intermediate output from the mapper to the different reducers. Okay, it's up to us. And from reducers we'll be having record writer based upon the output file format we mentioned. So in such a way we'll be given to the output file. I think I've done with the map reduce concept. Guys, if you have any questions you can ask me, or if you feel bored let me know. Yes, I have any questions. I'm unmuting you. I think you can able to unmute yourself. Yeah,
Yeah, no more.
yeah, any question you can ask me now.
I think everything is perfect. I just want to see the recorded section on few hours ago. Then I will ask. I will ask tomorrow. Now I'm good.
Okay, okay. Because this very if you understand MapReduce concept, almost 20% of things you can able to understand easily. If you understand.
Yeah, yeah. That's why I will see the recorded section once again, and then I will update you. If any questions is there, I will ask you tomorrow.
They design the slides like by keeping the partitioner in mind. Okay,
Okay.
everywhere they're
Okay.
mentioning the partitioner in mind. So partition is another separate
Okay.
topic that I will discuss later. That's what
Okay.
I mentioned. That is only one change
Yeah, yeah, sure.
in the diagram and the paint which I have drawn and the slides which is
Yeah.
okay. They all designed by keeping partitioner in mind. Partition is different.
Okay.
Okay. So any question, Nasim? Hello? Yeah, I think I can stop the recording and we'll see.
Yeah.